In this video, we demonstrate our group project for CS7450 Information Visualization. For our project, we worked with a dataset of student transcripts and admissions records provided by the Georgia Tech Office of Institutional Research and Planning. The Office of Institutional Research and Planning at Georgia Tech is responsible for collecting institute-wide data for planning and resource management to answer the broad question, what does Georgia Tech think? More specifically, one of their functions is to identify ways to improve the overall performance of undergraduate students. They want to improve freshman retention rates, improve graduation rates, and lower overall cost of attendance. Ways of doing this might be determining better admissions criteria to recruit and admit students more likely to be successful, improving advising to offer better individual degree planning strategies, and identifying students on the cusp to identify these students early and help them to retain their eligibility for financial support. We were asked to develop a visualization tool that could help to explore the very large set of student course records and discover features of course-taking patterns and strategies among students, keeping the overall institutional goals in mind. To this end, we present G-Transcript, an exploratory visualization tool which is aimed at helping IRP to investigate and identify course-taking trends in students. We will show three main parts of our InvoVis tool. 1. A heat map of major popularity over cohort. 2. A matrix of course co-occurrence within semester. And 3. Transcript details in a timeline view. The heat map gives an overview of the performance of all students of all the majors. The x-axis shows the cohort, whereas the y-axis shows all the majors at Georgia Tech. Each element of the heat map is colored according to the average GPA of all the students within a major in that cohort. The greater the average GPA, the darker the color. Additionally, you can sort the heat map by rearranging the major and cohort in ascending or descending order. This enables the user to get different perspectives of the same data. This view also allows you to view the average GPA of any batch of students by simply hovering above the respective element. Although the functionality is not complete in this demo, clicking on any element in the heat map should reveal the transcripts of all students belonging to that major and cohort in an area to the right. These transcript graphics are represented by time-ordered placement of contained rectangles. The rectangles are placed in stacks, ordered horizontally according to date, so that each columnar stack represents a semester. The rectangles are colored according to the grade result for the class. Hovering over any class element shows a tooltip containing the course name and the final grade earned. Clicking an element would highlight any occurrence of that same course in other visible transcripts. This would enable comparison of term when taken, relative order in scholastic career, and grade performance between students at a glance. The next view is the co-taken matrix view. The view shows the frequency with which two courses are taken within a semester. Here we have a filter, whose entries are the fields found on the transcript of every student. Using this filter, the user can narrow down the list of students, as well as specify the criteria for students whose courses they want to view. This selection results in a matrix view, whose axes depict the set of all the courses taken by the students, who satisfy the filtering criteria made by the user. The matrix view can be ordered according to the frequency and the names of the courses. Each grid is colored according to the frequency of the co-taken course, and hovering above each grid highlights the grid and the co-taken courses it represents. The next view is the representation of the transcript of selected students, placed according to their cohort and graduation date. Each wide area of stacked rectangles, a horizontal region, represents the transcript of a student. The stacked rectangles within these regions represent individual classes, and the tracks are placed according to date that the course was taken, as in the previous transcript view. The main difference here is the size of the course blocks is kept the same, and inset text shows the course code. Thus, this view helps the user to observe relative performance of students across different timelines, and see patterns in them at a glance. This concludes our description of G-Transcript, the result of our project for CS7450. We developed this web application using D3.js, Flask MVC for Python, and SQLite database. Thank you.